Hello everyone. In this video, we are just going to understand what you meant by multi-threaded approach. Let's get started. So this is the example that we discussed in the previous video where we just understood busy wait systems or busy wait approach or a sequential approach in a embedded firmware development. But this method will be problematic when it comes to safety critical applications like ABS systems, ventilators, etc. But if you take this same example with a multi-threaded approach, let's redesign this application with a multi-threaded approach. That is, what if we have two different kinds of threads, background thread and a foreground thread. Background thread will contain different tasks or functions for collecting the sensor data, and the foreground thread will be running the main function which will collaboratively collect all the data and then derive the results to the application. So let's consider we are having three different ISRs, that is interrupt service routine 1, interrupt service routine 2, interrupt service routine 3. First ISR will give us the pedal travel sensor data, second ISR will give the brake fluid sensor data, and the third ISR will give us the pressure sensor data. And just consider all these ISRs are providing the data whether based on a periodic interrupt or intervals or based on the availability of the sensor data. For example, if the pressure sensor data is readily available, this interrupt ISR 3 will interrupt the processor and it will give the data to the main function, that is the foreground thread. So this is the main thread. Just consider this is the main thread, and this main thread will be collectively running, and whenever the sensor data is available, or it will collect the each sensor data in a periodic fashion. And if you provide the priority to each of the ISRs or background threads, this system will be collectively called as soft real-time operating system. It is not actually a real-time operating system, but it can be called as a soft real-time operating system because it collects the data parallelly using ISRs, and it will process the same data that is collected in the main function, that is foreground thread right over here. But here also we are having a problem that most of the time will be spent right over here in the main functions other than the ISRs right over here. So the ISRs will be called only when the sensor data is ready or only when the particular time period for the ISR is allocated. So most of the time will be spent in the main function. So this is the main drawback of this particular multi-threaded approach. Remember, in the previous section we discussed key feature of RTOS is ability to derive right results with the specified time constraint, which is not possible here. What we need in the system is foreground thread with synchronization tools which allows thread to interact with each other. So that we will discuss in a while in the next upcoming videos. I hope you understood the multi-threaded approach in embedded firmware development in this particular video. See you in the next video. Thanks for watching.